Hello students, welcome to Study It Out. This question is from Physics, chapter Ray Optics. In the question it is given that a prism is made up of glass of unknown refractive index. A parallel beam of light is incident on the face of the prism. Angle of minimum deviation is measured to be 40 degree. What is the refractive index of the material of the prism? This is the first part of the question. And in the question, the refractive angle of the prism is given as 60 degree. Till here we can consider it as a first part of the question. In the second part, if the prism is placed on water whose refractive index is 1.33, predict the new angle of minimum deviation of the parallel beam of light. So let's understand this question with a figure. As you see in the figure, we have the incident ray. This is our incident ray. This incident ray touches the surface and gets refracted. So as it is moving from rarer to denser medium, so it will bend towards the normal. So when it comes to the next surface, opposite surface, then it is moving from denser to rarer medium. So in this case, it will go away from the normal. So this is our emergent ray. So suppose, assume that if there is no prism, so what will happen? The incident ray will go straight. But because of the prism, it will get deviated or deflected. So here, how much angle of deviation it will form, that we have to find it. And here in the question, it is also mentioned that this is our angle of the prism and its value is given as 60 degree. If in the question the refracting angle of the prism is given, it is our angle of the prism. So angle A value is given as 60 degree. Minimum deviation is given as 40 degree. We have to find the refractive index. So to find the refractive index, we can follow the refractive index formula with respect to prism. So the formula is mu is equal to, mu is the refractive index, sine minimum deviation plus angle of the prism divided by 2 and divided by sine A by 2. This is our general formula to find the refractive index. Now let's substitute the value. So we substitute the value, mu is equal to sine minimum deviation is 40 degree, angle of the prism is 60 degree divided by 2 and denominator is sine A by 2. So here it is 60 upon 2. So we can write it as sine 100 by 2 divided by sine 30 degree or sine 50 degree divided by sine 30 degree. So refractive index is equal to sine 50 degree divided by sine 30 degree. Let's substitute the value. Sine 50 value is 0.766. We can use a calculator to find it. This is 0.5. So mu is equal to 1.532. So we got the refractive index of the medium. Now in the second part, we have to find minimum deviation if the refractive index is already given. So here refractive index is given as 1.33 and here the prism is placed in the water. It means that what change happened in the second part? See, initially we assume that this is rarer medium is our air. Now the air is changed to water. So here we can say that actually it is present, this glass prism is present inside the water. These are the, assume that the water molecules are present. Now what is the new minimum deviation? One thing we have to understand, this refractive index 1.33 is actually the refractive index of water. And if we have to find the refractive index of the prism with respect to water, we need to use the relation of mu 2 1 is equal to mu 2 by mu 1. What is mu 2 and what is mu 1? Mu 2 and mu 1 are absolute refractive index. So here in this question, if this refractive index is given as 1.33 of water, actually it is absolute refractive index. And the refractive index that we just found, a refractive index of glass with respect to air, or you can say that we can consider air as a vacuum. So this is the absolute refractive index. So we already know the absolute refractive index of glass and we have absolute refractive index of water. So if we have to find the refractive index of glass with respect to water, it means that mu GW. So we use mu G by mu W. And mu G, how much we got? 1.532. And mu W is given 1.33. These are the absolute refractive index value. So refractive index of glass with respect to water is 1.15. So we got the refractive index. Now we have to find the minimum deviation. So again we use the same formula, but now what changes we have to do? This we already know. Here is the value 1.15. Angle of prism is not going to change. It remains as 60 degree. So based on this information, we have to find the minimum deviation. So let's solve it. Now let's substitute the value. This is 1.15. It's equal to sine. Minimum deviation we have to find. Angle of prism is 60 degree divided by 2 and the denominator is sine 60 by 2. So we can write it as sine minimum deviation plus 60 by 2. We can't solve it because we don't know the minimum deviation value, and this is sine 30. So we transpose it. So it can be written as sine minimum deviation plus 60 divided by 2 is equal to 1.15 into sine 30 degree. Sine 30 value is 1 by 2. So 1.15 into 1 by 2 is equal to 0.575. Now minimum deviation plus 60 divided by 2 can be also written as sine inverse 0.575. So the sine inverse of 0.575 is approximately equal to 35.10 degree, and this is the minimum deviation plus 60 divided by 2. So let's further solve it. Minimum deviation is plus 60 is equal to 70.20 degree. So minimum deviation is equal to 70.20 minus 60 degree. So this is equal to 10.20. So we can say that this is the answer of the second part of the question. If you have any doubt, you can mention it in the comment box. Thank you.